Hello guys. So now we are going to discuss about the capacitance of a capacitor when the dielectric medium is placed between that plates. So we have a dielectric medium of certain thickness. This is also called dielectric slab. So that is placed between the plates of the capacitor and the thickness of the slab is T. Okay. So now we have to find the capacitance of the capacitor. So what is the electric field over here? Electric field will start from plus and then it will go into the slab and then it will come out from the slab like this. So here, very important concept you have to keep in mind. Whenever electric field goes inside a dielectric medium, what will happen? Let's say this is electric field E, and whenever it goes inside the dielectric medium, its magnitude will increase, its magnitude will decrease by a factor of epsilon r. Okay, so you need to divide by the epsilon r because the electric field will decrease inside the dielectric medium. Very important concept. You have to remember this concept. Like this is the slab, and when electric field enters from air, so in air, let's say electric field is E, inside the medium, how much electric field we have? We have E by epsilon r. Very important concept. Whenever electric field enters into a medium, its magnitude will decrease by a factor of epsilon r. So you need to divide E by epsilon r. Okay, so very important concept. And now we'll further continue on this question. So first we need to erase this. Okay, so now here electric field is E, also here electric field is E, and here electric field is E dash. Okay, inside the dielectric medium electric field is E dash, which is E by epsilon r. E by epsilon r. Okay, so that's how we got the electric field inside the dielectric. Now when we talk about potential difference, so how we write potential difference? The distance between the plates is D. When we talk about potential difference, so how we write it? Let's say this thickness, take this thickness as T1, take this thickness as T2. Now here we have air, and here also we have air, and this is the dielectric slab. This is the dielectric slab. Keep this thing in mind. Now, whenever we write potential difference between the two plates, so you have to consider electric field, then corresponding length, plus electric field, corresponding length, plus electric field and corresponding length. That's how we write the formula of electric potential difference between the two plates. You just have to write electric field and corresponding distance, then electric field and corresponding distance, then electric field and corresponding distance. And if you have multiple mediums, so you can write for 10 mediums also. It doesn't matter actually. You can write for 10 different mediums like E electric field and distance and E into distance. So that's how we write the potential difference. Okay, the potential difference you can write very simply, just electric field into distance. Okay, now you can put the values over here. So delta V. Now from first and third term, you take E as common. So I'm taking E as common from the first and third term. What we got here? Now E dash is, we know that E by epsilon r, and then we have T. So like we got E common from the each term. So T1 plus T2, and you have T by epsilon r. And here we can write D is equals to T1 plus T plus T2. So what is T1 plus T2? D minus T. T1 plus T2 is equals to D minus T. Now you can put this value T1 plus T2. So we got D minus T plus T upon epsilon R. Epsilon R is the dielectric constant. And then we have delta V. Now, what is the value of electric field in air between the plates of the capacitor? The value of electric field in the air between the plates of the capacitor, we already aware of that thing. That is sigma by epsilon naught. Okay, so here it is same, and here also it is sigma by epsilon naught. So that is the value of electric field between the plates of the capacitor in air. So we got sigma by epsilon naught, and then we have D minus T plus T by epsilon R. Now just you can put the value of sigma. What is sigma? Sigma is Q upon area. Then we have epsilon naught. We got D minus T plus T by, this is the formula. And now we can find the capacitance by using Q is equals to CV. Okay, so the capacitance you can write like this, Q by delta V. Now just put the value of delta V. So how much we have delta V here? So let me, first you have to see it. Okay, that much. So we got Q epsilon naught, then we have A, in bracket we have T minus T plus T by epsilon R that we have, and we can cancel out Q and Q. So what we got? I think epsilon naught we have in divide. Epsilon naught in division. Let me correct it. Epsilon naught. So we have final answer epsilon naught A divided by T minus T plus T upon epsilon naught. So this is the expression of capacitance when the dielectric slab is placed between the plates of the capacitor, and that's very important question. And